All right, so we're going to be doing systems of equations, right? And systems of equations, you'll have two variables. With two variables, you need two equations, okay? Every single time. If you have two variables, two equations. Three variables, three equations. One variable, one equation, okay? That's how you will solve any equations with one or multiple variables, okay? Now, what we're doing is linear combination, right? There's a lot of different ways to do this. We can do linear, we can do substitution, we can do addition, subtraction, all sorts of things. But I only teach substitution and combination, okay? Because the combination is just straight addition, right? And I like to treat it like you would be bowling. Do the same thing every single time, right? And then it's not so bad. So what we're hopefully going to do is change these into equations that we can get rid of one of the variables. That's the whole key. If I get rid of one of the variables, then I'm left with one. With one variable, I can solve pretty easily, right? And I only need one equation with one variable. So what we're going to do is combine these two so that one of the variables go away, right? And you're left with one equation, one variable. And then you solve for it. To do that, I need to change, I got to find a number that 2 and 4 both go into, or that 6 and 8 both go into. So which one seems to be the easier one to deal with? X or Y? So, in other words, can I find a number that 2 and 4 goes into easier than I can find a number that 6 and 8 go into?
Yeah.
Yes. Why?
Because they're smaller and they have more common denominators.
Yes. So they're more common to each other. They have a common factors, right? And their factors are 2, right? And so 2 goes into 4, so it makes it even easier. So now I only have to actually change one of these. By multiplying this becomes a 4, right? So that's the same, and how do I make it opposite then? If I want to make it opposite, I would just use the negative, right? And so negative 2 times 2 is negative 4x. Negative 2 times negative 6y is positive 12y. And negative 2 times 12 would be negative 24. Okay? And then with this one, I don't even have to change it. I can multiply it by 1, which doesn't change anything. So I have 4x plus 8y equals 16. Okay? And so from here, I just add these two up. Now, these cancel. Okay? And so I'm left with 20y is equal to negative, and it looks like 4 and 4 is 8, so negative 8. Okay? Now that's going to come up with a pretty nasty fraction, right? So now I got to divide by. Right? And so at this point, right, now I've got y is equal to negative 8/20. Now, if I think about that, what goes into both of those? What goes in it? 2?
2/5.
Well, yeah, it's 2/5, but so how do I get down to 2/5? I could divide by 2, or I could divide by what you did, 4, right? If you only see 2, that's fine. 2 goes into 8 4 times. 2 goes into 20 10 times. 2 goes into 4 2 times. 2 goes into 10 5 times. Nothing goes into 2 and 5 except for 1, right? And so now I have my thing. So this is or negative 2/5, right? So y is 2/5, negative 2/5. Now I can plug that in and solve, right? Or I can change them again. So since a lot of us don't like dealing with fractions, we tend to we want to change this all over again. So it's 2x minus 6y equals 12, and 4x plus 8y equals 16. And we got to think of a number that 6 and 8 both go into. What is a number that 6 and 8 both go into? 24. Okay. So how do I turn 6 into 24?
Times 4.
Times 4. So 4 times 2 is? 4 times 8 is 6. 4 times 12. Right? And then how do I change 8 into 24?
3.
3? Okay. Alright, so now, are they going to be opposite? This is negative 24, this will be positive 24. So they are already going to be opposite. So I don't have to multiply by a negative this time. I get to just multiply by 3. 3 times 4? 12. 3 times 8? 24. Right? And 3 times 16 will be 30 plus 18, which is 48. And so I'm going to add these two up. Right? And again, these guys cancel. Now the y's cancel this time. This becomes 20. There's an x here. Sorry about that. 20x equals, and 48 is?
Yeah, I'm saying put x's next to the y's.
Did I put the y? Oh, my bad. I did. These are y's. Thank you. Silly me. Thank you. So we got 20x is equal to 48 and 48, which is 80 plus 16, or 96. Okay. And then we got to divide 96 by 20, right? So here we go, back to the dividing. So x equals 96 over 20, right? And I can break that down. Now I can turn it into a mixed fraction first or later. It's up to you, right? So what do you want to do, first or later? You want to see how many times 20 goes into 96? First, right?
It's like 4 times.
So 4 times, right? Good. So 20 goes into there 4 times, with how many left over? 16. Good. 16 left over the 20. Okay. And now we can take that 16 20ths. We say, well, what goes into both of those? 4. Okay. So 4 goes into 16 4 times. 4 goes into 25 times. Does anything go into 4 and 5 besides 1?
No, it's just 4.
So it's just 4/5. So now we can say or,
4.
and that's a V. Sorry about that. Or 4 and 4/5. Okay. So now we know that x is equal to 4 and 4/5, and y is equal to negative 2/5, and that's what's going to make these work. Now remember, the whole key in the beginning was the fact that this was a perpendicular, right? And these were equal to, oh, sorry, we weren't doing the perpendicular that time. We were just doing systems of equations, which is fine. And now we can do one that's actually for your test.